Hello friends, I welcome you to my YouTube channel Back PM. So in this video we will derive formula for the strength of fillet welded joints. So what is fillet welded joints? So see this portion, this is called fillet. Okay, so this extra material which we are adding to weld these two plates. Okay, so we will find what is the formula for the strength of this fillet. So we will do three cases. First one is single transfer fillet weld. Second one is double transfer fillet weld. So what is transfer? So transverse means, suppose this is the direction of load in this direction, then welding is perpendicular to the direction of load. So this is called transverse fillet weld. And this is double parallel fillet weld. See here, welding direction is also same to the load direction. Okay, so this is parallel fillet. And third one is combination of fillet and transverse. So let's see how to derive the formula. So first of all, this is single transverse fillet weld. Okay, so in this case we have zoomed this portion and we have taken the diagram of this fillet here. Okay, so we are assuming that it is triangular. Okay, these two are equal side. So from this diagram here you can see T is called throat. T is throat of the fillet or weld. Okay, this is equal to BD. It is minimum length of welding or minimum at this along this surface area of the welding will be minimum. Okay, if you take this is longer, so this is shortest length of fillet weld. Okay, S, see this is S, this is also S. This is called leg of the welding. L is length of the welding. So L is not visible in this diagram, but you can see if we draw a plate like this. So this, suppose this is welding, so this total length of the weld is L. Okay, or in this diagram you can see L. See, this is L, length of the welding. Okay, we are seeing only from the front view in this diagram, but this is top view. Here you can see the length of the weld. L is length of the weld. Okay, so from this diagram, if from this triangle, this is 45 degree and this is also 45 degree. So if you try to find BD, so T is equal to BD, which will be equal to, this is 90 degree. Okay, so sine 45 degree is equal to BD upon this S. So BD is equal to S sine 45 degree, or sine 45 degree is 0.707. So BD T is equal to 0.707 S. Okay, so this is a relation of throat and leg of the welding. So what is the area? Minimum area. So this is the minimum length of this welded portion. So this is minimum length. So area will be length into width. So this is width and length is perpendicular to this plate. This view from top view we have seen. So area is equal to T into L. So it is 0.707 S into L. So this is area. Now we have seen from the above figure, load is being applied perpendicular to this. So this is under tensile stress. Okay, so if maximum allowable tensile stress is sigma T, then what will be the strength of the plate will be area into sigma T. So it will fall along the minimum surface area, minimum thickness. So this is the minimum area along this line, so it will become area is equal to 0.707 SL into sigma T. Okay, so this is strength of single transverse fillet weld. Okay, now if we take the second case, in this case there are two weldings. Okay, so strength will be doubled. Okay, the effective length will be 2 times. Okay, so P will become 2 into 0.707 SL sigma T, or 1.414 SL sigma T. Okay, so this is strength of double transverse fillet weld. Okay, now in case of, if we see next case, this is parallel fillet weld. So this is parallel. Here also there are two welds. Okay, so what will be the area? Area will be same like previous case. Area is equal to 0.707 S into L. Okay, so in this case you can see that this weld is under shear. Okay, so this is under shear, so maximum allowable shear stress is tau maximum. Then P will be, there are two weldings. Okay, so 2 into, suppose this is L, length of the weld, 2 into L into 0.707 S into tau max. So if you will do this, you will get 1.414 SL tau max. Okay, so this is strength of double parallel fillet weld. So in this case, if you see, there is one transverse and two parallel fillet welds. Okay, so in this case strength will become, for one transverse, what is 0.707 SL1, this is length L1, and sigma T plus 1.414, because two parallel fillet welds, SL2 into tau. So this is strength of the combination of transverse and parallel fillet weld. So I hope you understood how to find these formulas. So based on these formulas, we will try to solve some numerical problem in our upcoming videos. So I hope you remember this formula, so that we can directly apply in the question. Okay, thank you for watching.